Welcome back. Today what we're going to do is continue the use of the equations that we started earlier this week. I recognize that it was a lot of math, and some people did get tripped up solving for the variables, so I do want to spend some time going through how to actually solve these equations appropriately and kind of get a little bit more to the concept of energy, total energy. So I've had a picture here of some energy drinks. And do energy drinks actually give you energy? Well, they have sugar. Sugar is food, calories, joules, so they do. They also have a bunch of other stuff there that is supposed to just heighten your senses, and it's not that good for you. Wouldn't recommend drinking it on a regular basis. Every now and then it's probably fine, but if you drink these things fairly regularly, you could develop some health issues. I wouldn't recommend it. Okay, so quick review. We have two types of energy that we've been talking about, potential and kinetic. When I say potential energy, I mean the energy of position, height, where it is. Potential energy is essentially how high the object is, how much potential it has to fall. Kinetic energy is the energy of motion. So this is just a quick recap. And I think I ended the last time. In fact, no, there's no thinking, I know. And I said that the total energy equals the potential energy plus the kinetic energy. And I solved problems out like that. But I didn't give you this equation. But if you look at it, technically, this equation is exactly the same. Because all I'm doing is, instead of writing PE is, potential energy is mass times gravity times height. Instead of writing KE, it is 1/2 mv squared. But I want us to try to feel comfortable using this equation as a whole so that perhaps we can solve for some other quantities more than just potential and kinetic energy. What do you mean? Well, let me show you. So this is what is the total energy of a 2 kilogram basketball, 2 meters high, rolling 2 meters per second. This is actually really simple. This is not very hard. This is what we did last time. You just plug the numbers into the equations and you solve and you add. I said this is the potential energy, this is the kinetic energy, you just add them and that's how you get the total energy. So I'm not changing anything that we did last time. I'm just going to add one small thing to it. Okay. This one says, how high is a 3 kilogram bird flying that has a total energy of 264 joules while flying at 3 meters per second? So we now have a new equation. TE equals mgh plus 1/2 mv squared. So when it says how high, we're looking for the height. So h equals question mark. 3 kg is the mass. Total energy. Okay, so unlike last time, if I'm saying total energy, we know it's the total energy. So I can just say the TE is 264. While flying 3 meters per second. Meters per second is a velocity. So, okay, I think I get the hang of this now. All you're going to do is plug these values into this equation and solve for your variable. It's a lot of math, but it's not that hard. So let's see how this goes. 264 goes in for the TE. The mass is 3. G is gravity, in this case positive 10. H, that's what we're looking for, so that's going to be our variable. Plus 1/2, 3. The mass is 3 and the velocity is also 3. 3 squared. All right, I'm going to type that in my calculator. 3 squared times, I type all that in my calculator and I get 13.5. I actually knew that. I don't know why I had to do that. Equals 30H. plus 13.5, and I bring down the 264. Sorry about that. There we go. Cool. So we just multiply the 3 by the 10, you have 30. So what I'm going to do is I'm going to minus 13.5 from both sides. Minus 13.5. Okay. So I have 264 minus 13.5. Then I have 250.5 equals 30H. Divide both sides by 30. Okay, easy. And I get 8.35 meters because we solve for height. Height is measured in meters. That's it. So not anything actually new. We're just putting it all together and solving for different things today. It's really important that we understand how these calculations work. But what about something like this? How fast? How fast means we're looking for velocity. Okay? 2 kilograms, 2 kg, all right? 2 kg is, of course, mass. That is 4 meters, okay? 4 meters above the ground, so that's got to be a height. Okay. And then a total energy of 96, and because it just straight up says total energy, so I'm going to write TE 96. Okay, cool. So I'm going to write out that equation, and if you have not copied that equation down into your notes, I'd recommend doing so. Make your life a little bit easier, rather than keep pausing this video, going back, finding the spot. Hold on one sec. Oh, much better. My mouse is having issues. I just have to fix that up. Okay. There you go. There's the equation. So for those of you who take notes, please add that equation to the notes. And for those of you who take notes, I mean all of you, because obviously all of you take notes. The mass is 2. Gravity is 10. The height is 4. Plus 1/2. The mass is 2. And we're looking for the velocity. Okay, so this is what we're going to do. 2 times 10 times 4, you just multiply all that together, you get 80. Half of 2 is 1, so that just goes away, you know, kind of 1 in front, v squared equals 96. Minus 80 from both sides, minus 80 from both sides. 16 equals v squared. All right. Because technically I have to divide by 1, but that doesn't really change anything. So the square root of v is going to be 4. Again, nothing we haven't done before. Now, actually, I say nothing we haven't done before. This is something we haven't done before. What is the mass? Mass equals question mark of a branch that is falling 8 meters per second. So the velocity is 8 meters per second, while it is 12 meters high. Okay, I'm just going to fill in all these variables with a total energy of 1672 joules. Okay, so here's the equation. TE equals mgh plus 1/2 mv squared. Now the reason why this one is a little tricky is because there's an m in both the PE and the KE. There's an m here and an m here. So let me just show you how this math is going to work out. 1672 equals m, gravity is 10, height is 12, plus 1/2 m, and then the velocity is 8 squared. Okay, what can we combine? All right, so I'm going to bring the 1672 down, equals 10 times 12 is 120. I'm going to call this 120 m plus 8 squared is 64. Good. Okay, so far so good. So when the half is in front, what I can do when it's all together, I could just take half of 64. And that's exactly what I'm going to do. So I'm going to bring everything down again. 1672 equals 120 m. Half of 64 is 32. So this is just 32 m. Oh, we've never gotten to something like this before. But because these are both m's, they're like terms. If they're like terms, you can add them. So I can actually call this 152 m equals 1672. And all I have to do is divide both sides by 152 to get the answer. You divide by the number in front of the variable. And that would be 11 kilograms is the mass. Again, nothing crazy. Nothing crazy. You can do this. Once you know how to do this, guys, you can only solve for mass, height, or velocity. And we just did a problem on each of those. So you can't get any trickier than that. Okay, so here's another one, a little bit trickier because it says, what is the height? Height equals question mark, 6 kg. Okay, so 6 kg is mass. Stone at rest. Oh, when I see at rest, that's telling me something. That's telling me that the velocity is 0. That is very important. That's kind of why I'm going through this again. With a total energy of 0. Wait a minute. Hold on. If the total energy is 0, yeah, I could plug it into the equation. I could do all that. You would absolutely get the right answer. So I'm not saying you can't. But if I know the total energy is 0, that means the PE and the KE both have to be 0. The only way the KE can be 0 is if the velocity is 0, which it is. And the only way the PE can be 0 is if the height is 0. So just little tricks here to help you do these problems a little bit faster. If you could notice something like that, that would really help. Because the total energy is 0, the height has to be 0. And that's it. It's a lot of math, but if you just go step by step, you're going to be fine. And if you need any help, if you have any questions, I have office hours every day from 12:30 to 1:30. So join me there. It'll be a good time. You all be well, and let me know what I can do to help.